Today I am going to introduce the concept of random variables. So, let us recapitulate what we have done till now. We have considered that there is a random experiment. The set of all possible outcomes is called a sample space. Then any subset of the sample space is an event. We have studied various methods of calculating probabilities of events. We have given an axiomatic framework. In that axiomatic framework, we can calculate probabilities of various combinations of events. For example, there is a formula for union of the events. What is the probability of conditional probability? We have defined Bayes theorem, etc. We have also studied the concept of independent events. Now, what happens that many times we are not interested in the full description of the event, rather we are interested in some numerical characteristic associated with that. Let us consider say a match, say for example, it is a badminton match. Now, in a badminton match we can look at the outcome. So, it is in the form of some score. So, for example, 21-19, that means the winning player in a game made 21 points and the losing player made 19 points. If we consider a game of tennis, then we can look at the points. So, there are sets and the sets scores are given like 6-4, 6-4, 6-3 kind of thing, or 7-5. So, actually the full duration of the match may have lot of facets, that means how many aces were served, how many double faults were there, but ultimately we look at the score. Similarly, if you look at a cricket match, then we may look at the scores scored by say certain players or the wickets taken by certain players. That means to various events we are associating numbers. This you can consider in other ways also. For example, let us look at some real life situation. A patient goes to the doctor. Now, he will get some medicines. Now, after the taking the medicine, the outcome is to be seen as whether he is getting cured or he is not getting cured. Similarly, from the doctor's point of view, we can see that he is treating patients. So, for example, in a day he treats 20 patients. Now, out of those 20 patients, how many actually got benefited? Say maybe 18 got benefited, 2 did not get benefited. So, if we look at this kind of thing, so we are actually looking at certain numbers associated with events. Now, this association can be described by the concept of random variables. Let us look at simplest example. Suppose we consider a basketball game and we see how many successful basket hits are done by a player A. So, in that case, then this number say x is a numerical valued variable. Now, since the playing of the match and how many he will be successfully hitting, that itself is a random event, therefore, this becomes a random variable. Since the success in hitting the basket is random, we call this as a random variable. So, let us consider say we consider tosses of 3 coins Okay. Now, the outcomes are the sample space can be written as all the 3 heads, 2 heads and 1 tail, which can be in the form of HHT, HTH and THH, or you can have 2 tails, or you can have all the 3 tails. But we are not interested in the actual outcome, rather we are interested in how many heads are observed or how many tails are observed. So, I define from this experiment, let x denote the number of tails, then x can take values 0, 1, 2 or 3. In fact, now you can see I want to put a value corresponding to each element of the sample space. So, for example, I can say x of HHH is 0 because there is no tail here, x of HHT is 1 because there is one tail here. Similarly, if I look at x of HTH, then this is equal to 1. If I put x of THH, then this is 1. Then if I put x of HTT, then there are 2 tails. What is x of THT? That is 2. X of TTH is equal to 2 and x of TTT is equal to 3. So, what we have done, to each element of the sample space we have associated a real number. So, this assignment by using a function, we are using the function x here, this x is called a random variable. Thus, x assigns a real number to each element of the sample space. So, x is called a random variable. So, let me give a formal definition of the random variable. A random variable x is a real valued function defined on the sample space. Let us follow the popular terminology which you use in mathematics. How do you write a function? You write a function like f is from a to b kind of thing. So, that means here x is from S to the set of real numbers. S is the sample space and R is the set of all real numbers. So, x is actually a function, but in probabilistic terminology the convention is to call it a random variable. Okay, so, the name can also be explained. It is a variable because depending upon different outcomes it takes different values, and those outcomes are coming from a random experiment. Therefore, it is called a random variable. Mathematically, it is a function. That means, to each omega belonging to S, x omega is a real number. So, examples of random variables can be, for example, if I look at height of an adult male. So, this will be some number. So, taking the extreme case that somebody can be say 4 feet. So, that means say around 120 centimeter, and somebody may be as high as say 8 meter, taking the extreme case 8 feet. So, maybe is 240 centimeter kind of thing. So, we can have the set of values x taking values between say 120 to 240 centimeter. Suppose I consider age of a person. So, age of a person can be from 0 to any. So, suppose I am considering in numbers. So, maybe the oldest known person may be maximum 120 years of age. So, you can put 0 to 125 years. Number of attempts needed to hit a target. Then what are the possible values of this? It can take value 1, you can hit in 1, you can hit in 2 and so on. You can see then the type. I gave an example where the random variable is taking values 0, 1, 2 or 3. I have given an example here where the values taken are in an interval, that means uncountably infinite number of values. Here you can see number of attempts, so 1, 2, 3 and so on, it is countably infinite number of values. So, a random variable based on this description can be described as either the one which takes a finite or countably infinite number of values, that means you can write 1, 2, 3 and so on, say up to n, or 1, 2, 3 and so on infinitely many, that means you can say countably infinite number of values. Or if you say height, age, weight, lifetime, etc., then these are all examples of continuous random variables, because the random variable takes values over an interval. In your class 11th and 12th, you have in the syllabus discrete random variables. So, I will describe in detail the probability distribution of a discrete random variable, how to find out its expectation or the mean, etc. So, if a random variable takes a finite or countably infinite number of values, then it is called a discrete random variable. If the random variable takes values over an interval, it is called a continuous random variable. Actually, there are finer distinctions based on the representation of the probability distribution, but at this stage we will take these definitions as the definition of discrete and continuous random variables. When you will go to the advanced classes, then you will learn the more rigorous definitions of the random variable. For example, it is a measurable function. So, but in the class 11 and 12th level, we do not study into that depth. So, you should understand the method of finding out the probability distribution for a discrete random variable, that is in your syllabus. So, we will spend some time on that. So, thus we can say that for a discrete random variable x, the set of all possible values can be described by, so I will use some notation, say E is equal to say x1, x2 and so on xn, or x1, x2 and so on. So, either you have a finite number of elements, say n elements, or you have an infinite number of elements, but they can be counted. So, it is countably infinite number. Now, in the original random experiment, based on the description of the experiment, various events or various outcomes are allocated certain probabilities. Now, when those events are transformed to values, so each element is transformed to a value using the random variable, then the corresponding probabilities can be associated with those values. That gives rise to a discrete probability distribution. So, let me talk about this. The probability distribution of a discrete random variable is an assignment of probabilities to each value that the random variable x may take. So, let me keep this sheet here to consider what are the possibilities. So, if I consider the random variable x taking values x1, x2, xn, then if I allocate the probability p of x1, so we can write probability x is equal to x1 is equal to say p1, probability of x is equal to x2 is equal to p2 and so on, probability of x is equal to xn is equal to pn. Now, you can see that all the possibilities of the random sample are allocated the values x1, x2, xn. Now, in the original sample space, when the allocation of the probabilities was there were some conditions which were satisfied. For example, sum of all the probabilities is 1. Now, those probabilities have been transformed to p1, p2, pn. Therefore, the sum of pi's must be equal to 1. Also, these are all probabilities. So, all the probabilities must be non-negative. Now, in the discrete random variable, we will talk about exactly those values which are assigned. So, that means the probabilities are actually positives. So, we can say that pi is positive for all I and sigma pi I is equal to 1 to n is equal to 1. Then this p1, p2, pn is called the probability distribution of random variable x. So, here we are dealing with the discrete random variable x, and I am assigning the probabilities p1 to x1, p2 to x2, pn to xn. Then this p1, p2, pn is called the probability distribution of the random variable x. Let me calculate it for one case. Consider this example of tossing of 3 coins. If I assume the coins to be fair, then we can calculate the probabilities here of each value. Consider the experiment of tossing of 3 fair coins, and here x is the number of tails. Then let us calculate the probability distribution. What is the probability that x is equal to 0? Now, x is equal to 0 is corresponding to when all the 3 heads are observed. So, it is actually equal to the probability of the possibility h h h. So, this is 1 by 8. Similarly, if I look at what is the probability of x is equal to 1, then from the experiment you can see that x is equal to 1 is when one tail is observed. So, HHT, HTH and THH. So, this we can write as HHT, HTH and THH. So, this probability is 3 by 8. So, we have calculated the probability of x is equal to 1. Similarly, if I look at what is the probability of x is equal to 2, then you can see that x takes value 2 when 2 tails are observed, that is corresponding to HTT, THT and TTH. So, that is probability of HTT, THT and TTH. Again you can see that this probability is equal to 3 by 8. Similarly, you can see P3, that is the probability x is equal to 3. So, x is equal to 3 when all the 3 tails are there. So, it is the probability of TTT, that is 1 by 8. So, now you can see I have calculated the probabilities corresponding to all the possible values of the random variable. For x is equal to 0, P0 is 1 by 8, P1 that is the probability x equal to 1 is 3 by 8, P2 that is probability x equal to 2 is 3 by 8 and P3 that is the probability x equal to 3 is 1 by 8. So, if you look at the sum of these, it is equal to 1 by 1 plus 3 plus 3 plus 1, that is 8 by 8. So, that is 1. You are having P0 plus P1 plus P2 plus P3 is equal to 1. So, this is a valid probability distribution here. Let me take another example. Suppose there are 10 bulbs in a pack, out of which 3 are defective. A customer buys 2 of these at random. Okay. in a pack of bulbs there are 10 bulbs, out of which 3 are defective, and a customer buys 2 of these at random. Now, certainly when he is buying 2, there can be some defectives there. So, let x be the number of defectives purchased by the customer. Then what are the possible values of x? X can take values. So, out of 2 maybe all are good. So, that means 0 defectives, 1 may be defective or both may be defective. So, this is x is a discrete random variable. Now, we want to calculate the probability distribution of x. That means, what is the probability x equal to 0, what is the probability x equal to 1, and what is the probability x is equal to 2. So, in order to calculate this, let us look at the calculation of various possibilities. If we are considering choosing of 2 bulbs from a pack of 10 bulbs, then the total number of possibilities is 10C2. Now, if I say that none of them is defective, that means customer chose 2 and he got both good ones. Now, out of these 10 bulbs, 7 are good, that means his selection is from those 7. So, it is 7C2 divided by 10C2, that means the favorable number of cases is 7C2 and the total number of cases is 10C2. Now, this can be easily simplified. So, this is giving 21 by 45. This can be further simplified. I have not simplified intentionally, just to show that the sum is all right. Similarly, let us consider P1. What is the probability that x is equal to 1? Once again, the total number of possibilities is 10C2. Now, if 1 is defective, that means 1 is non-defective. So, that means out of 7 he gets 1 good one, and from the 3 defectives he chooses 1. So, the favorable number of cases is 7C1 into 3C1 divided by 10C2. So, that is again 21 by 45. So, that you can actually write as 7 by 15, this is also 7 by 15, and P2, that is the probability that x equal to 2, that means he got both the defective ones. So, 3C2 divided by 10C2, that is equal to 3 by 45, that is equal to 1 by 15. This is the probability distribution of the number of defectives. You can see here 7 by 15 plus 7 by 15 plus 1 by 15, the sum is equal to 1. So, this is a valid probability distribution of the discrete random variable x, which is defined as the number of defectives in the purchase by the customer. Let me take one more example here. A card is drawn at random from a well shuffled deck of 52 cards. That means the complete set is there of 52 cards. From there, one card is drawn at random. If the card drawn is any number between 2 to 10, then its score is that number. That means, if we draw a 2, then the score is allocated as 2. If we draw a 5, then the score allocated is 5. If the card drawn is king, queen or jack, its score is 15. If an ace is drawn, its score is 18. Okay, so let us look at the random variable. Let x denote the score. Then what are the possible values of x? The possible values of x are 2, 3 up to 10. If the king, queen or the jack is drawn, the score allocated is 15, and if an ace is drawn, the score allocated is 18. So, the values that x can take is 2, 3 up to 10, 15 and 18. So, it is a discrete random variable. Let us calculate the probability distribution of this. So, what is P2? That is probability that x is equal to 2. There are 4 cards which carry the value 2. So, 4 by 52, that is equal to 1 by 13. Similarly, if I look at P3, again there are 4 cards that carry the value 3. So, it is 4 by 52, that is equal to 1 by 13. Up to P10 you will have same value. If I consider P15, that is the probability x equal to 15. Now, 15 is recorded when 3 cards are there, king, queen and jack. There are 12 such cards. So, you get 12 divided by 52, that is equal to 3 by 13, and the probability of 18, that is probability x equal to 1, x is equal to 18, that is when an ace is observed. So, again it is 1 by 13. So, this is the probability distribution of this random variable x. You can look at the sum. You have 9 values here, 9 by 13 plus 3 by 13 plus 1 by 13, that is equal to 1. Now, if a random variable's probability distribution is there, we can calculate various probabilities. So, for example, if I am looking at the number of tails, I can ask what is the probability that an odd number of tails are observed. So, for example, odd number of tails will be probability x equal to 1 plus probability x equal to 3, that means 3 by 8 plus 1 by 8. I can ask what is the probability that x is less than or equal to 2. So, if I say probability x is less than or equal to 2, it is probability x equal to 0 plus probability x equal to 1 plus probability x equal to 2, that is 1 by 8 plus 3 by 8 plus 3 by 8, that is 7 by 8. The point I am trying to make is that given a probability distribution, we can resolve the probability statements corresponding to that random variable. So, let me just calculate few of these probabilities here. We want the probability that the score is at least 10. That means, what is the probability? X is greater than or equal to 10. That is equal to probability x is equal to 10 plus probability x equal to 15 plus probability x equal to 18. These are the possible values that the random variable can take, which are not less than 10. So, this is equal to 1 by 13 plus 3 by 13 plus 1 by 13, that is 1 by that is 5 by 13. Apart from calculating the probabilities of various values of the random variable, one can also calculate its mean, or you can say the central point of the distribution. If you remember your statistics portion, given values x1, x2, xn in the sample, you are calculating arithmetic mean, which you are calculating by looking at x1 plus x2 plus xn by n. Or if the frequency distribution is given, for x1 you have frequency f1, for x2 you have frequency f2, for xn you have frequency fn, then you are calculating x1 f1 plus x2 f2 plus xn fn divided by sigma fi. And what was the purpose of that? It gives you a measure of central tendency for that data. Similarly, when the random variable is taking values x1, x2, xn with probabilities p1, p2, pn, we can calculate x1 into p1 plus x2 into p2 plus xn into pn. This is called the mean of the discrete distribution of the random variable x. Let us define that. Let x be a discrete random variable with possible values in E, that is x1, x2, xn, and the corresponding probability distribution p1, p2, pn. The mean of x or expectation of x or expected value of x is defined by, so this is the notation, expectation value is defined as Ex, that is x1 into p1 plus x2 into p2 plus and so on xn into pn, that is equal to sigma xi into pi, I is equal to 1 to n. So, you can see here what are the values that the random variable takes. We consider those values and multiply them by the corresponding probabilities and sum it. So, then it becomes the mean or the expectation of the random variable. So, let us look at the distributions that we have done. So, we had this distribution of the number of tails in the 3 tosses of a coin. Let us look at what is the mean here. Distribution of number of tails. So, for your reference I will again write here, it was P0 was 1 by 8, P1 was 3 by 8, P2 was 3 by 8 and P3 was 1 by 8. So, the mean or the expected value is 0 into 1 by 8 plus 1 into 3 by 8 plus 2 into 3 by 8 plus 3 into 1 by 8, that is equal to 12 by 8, that is equal to 3 by 2. Now, one may wonder that what is the meaning of this? I am getting a fraction. Actually, the number of tails is 0, 1, 2 or 3. So, that is an integer value. The expected value or the mean does not mean that it has to be one of those values, but it is some intermediate value here. The values are 0, 1, 2. Actually, you can see here, if I consider the plotting here. So, suppose I put a 0 here, 1 here, 2 here and 3 here, then on this side we are putting pi. So, 1 by 8, then this is 3 by 8, then this is 3 by 8 and this is 1 by 8. So, this is 1 by 8, this is 3 by 8, this is 3 by 8 and this is again 1 by 8. Okay. So, you can see here that the value that I am getting as the mean is 3 by 2, that is coming here, that is something like a mid value, and that is happening because it is a distribution which is symmetric. That means from both the ends I am giving equal probability to 0 and 3 and equal probability to 1 and 2. So, that is why the mean value is turning out to be in the middle. Let us look at the other example of the number of defective bulbs. Number of defective bulbs. So, here P0 was 7 by 15, P1 was 7 by 15 and P2 is equal to 1 by 15. So, expectation of x becomes 0 into 7 by 15 plus 1 into 7 by 15 plus 2 into 1 by 15, that is equal to 9 by 15, that is equal to 3 by 5. Again you can see the number of defectives is 0, 1 or 2, but the mean value or the average value is not an integer. Actually, it is a fraction which is below this. If you plot the distribution here, at 0 you are having 7 by 15, at 1 you are having 7 by 15 and at 2 you are having 1 by 15. So, this average is coming somewhere here, that is 3 by 5, somewhere here you are getting. Let us look at another example of the score of the card drawn. So, here we have this probability distribution. Let us look at the mean. Score of the card. So, here the distribution was, let me rewrite the distribution. Probability x is equal to I was 1 by 13 for I is equal to 2 up to 10. Probability x is equal to 15 was 3 by 13 and probability x is equal to 18 was 1 by 13. So, expectation of x becomes I into 1 by 13 for I is equal to 2 to 10 plus 15 into 3 by 13 plus 18 into 1 by 13. This sum you can do by the summation of the positive integers formula, like the sum from 1 to 10, you know that it is n into n plus 1 by 2. So, that is 10 into 11 by 2, that is 15, and the first term is not there. So, it will become 54. So, 54 plus 45 plus 18 by 13. So, that is equal to 9. Expectation x is equal to 9, that is the expected score of the card is 9. Now, let me also introduce another quantity, that is called the variance. So, I have explained that expectation is something like average value or the mean value, but we may also like to see whether the values are distributed more, that means they have lot of variation or they have less variation. Let us consider the concept of variability. So, let us take probability x is equal to -1 is equal to probability x equal to 0 is equal to probability x is equal to 1, it is equal to say 1 by 3. Okay. That means -1, 0 and 1, each of them is having equal probability 1 by 3. Okay. So, if you look at the expectation of x, that is equal to -1 into 1 by 3 plus 0 into 1 by 3 plus 1 into 1 by 3, that is equal to 0. Let us take another example. Probability x is equal to -2 is equal to probability x equal to 0 is equal to probability x equal to 2 is equal to 1 by 3. Again you can see expectation of x is equal to -2 into 1 by 3 plus 0 into 1 by 3 plus 2 into 1 by 3, which is again 0. But if you plot it, how you looks like -2 and plus 2, 1 by 3, 1 by 3, 1 by 3. So, if I compare these two graphs, you can see that the random variable x here takes values which are having more variation compared to this random variable. Let me rename these variables. So, I call this as x1 random variable, and this random variable I call x2 random variable. Then what we are observing is that expectation of x1 and expectation of x2 is 0, and the random variable x1 gives equal probability to -1, 0 and 1. The random variable x2 gives equal probabilities to values -2, 0 and 2. Now, visibly I can see that these values are near, these values are slightly away, there is a more variation here. In order to measure that, we introduce a concept called variance. So, let me define that. Variance of a random variable x is defined by, so we call it var of x, or sometimes it is written as v of x. Okay. It is nothing but expectation. So, expectation terminology I have already introduced. So, let us see expectation of what. So, x minus mu square. So, let me define where mu is used as a notation for expectation of x. So, now you can see what I am trying to look at. If mu is the mean of x, then I am looking at how much variation is of the random variable from the mean value. This is what was little bit of intriguing in these two examples. If you look at here, the mean is 0 and the other values are 1 and -1. Here the mean is 0 and the other values are 2 and -2. So, obviously, these values are farther away from the mean value compared to this. So, let us look at this variance of x1 and variance of x2. So, variance of x1, that is expectation of x1 minus mu1, say, where mu1 is the expectation of x1. Obviously, here mu1 is 0. So, this value is equal to expectation of x1 minus 0 square, that is expectation of x1 square. I have already introduced the formula for expectation. It is value multiplied by the probability. So, what are the values of x1? Minus 1. So, minus 1 square becomes 1, the probability is 1 by 3, 0, 1 by 3 plus 1. So, 1 square is 1, 1 by 3. So, this value is equal to 2 by 3, that is the variance of x1. Let us look at the same thing for the random variable x2. So, for the random variable x2, variance of x2, that is expectation of x2 minus mu 2 square, where mu 2 is nothing but the expectation of x2. Once again, expectation of x2 is 0. So, this becomes expectation of x2 square. x2 is taking values minus 2. So, minus 2 square is 4 into the probability of x2 is equal to minus 2, that is 1 by 3 plus 0 into the probability plus 2 square is 4 into 1 by 3, it becomes 8 by 3. So, let us compare the variance of x1 and the variance of x2. So, you can see here variance of x1 is 2 by 3 and variance of x2 is 8 by 3. Naturally, x2 is having more variation than x1. So, this concept of looking at that there is some variation in the random variables. So, whether there is a less variation or there is a more variation, this concept can be formally studied using the term variance. So, thus variance of x2 is greater than variance of x1. Thus, we can see that random variable x2 has more variation than random variable x1. So, we can actually calculate variance in various examples that we have done. So, number of tails. So, we had here P0 was 1 by 8, P1 was 3 by 8, P2 was 3 by 8 and P3 was 1 by 8, and expectation x, which we call mu, that was equal to 3 by 2. So, let us calculate here variance. So, variance of x is equal to expectation of x minus mu square, that is expectation of x minus 3 by 2 square. We have to substitute the values of x. So, that is 0 minus 3 by 2 square into the probability, that is 1 by 8 plus 1 minus 3 by 2 square into 3 by 8 plus 2 minus 3 by 2 square into 3 by 8 plus 1 by 8, sorry, 3 minus 3 by 2 square into 1 by 8. So, this you can easily calculate, it is 9 by 4 into 1 by 8 plus 1 by 4 into 3 by 8 plus 1 by 4 into 3 by 8 plus 9 by 4 into 1 by 8. So, these values turn out to be 24 by 32, that is equal to 3 by 4. So, I have given the example that how the variability of the distribution can be calculated. We have introduced the discrete random variables, the random variables which take a finite or a countably infinite number of values. Although all the examples that I have taken there, we have taken finite number of values. I will discuss in detail some other examples where even infinite number of values are permitted, and I have introduced the concept of expectation or the mean and the variance. In the next class, I will further enhance this concept by using the a special discrete random variable called a binomial random variable.